Hi, welcome to Stormwater Basics. How stormwater is different from our drinking water and our wastewater. This presentation was originally presented on December 14th, 2021, and this is a recording of that presentation for your convenience. Without further ado, I'm going to switch into the presentation and get started. My name is Marty Cieslik. I'm the construction manager for the City of Verona Public Works Department. And thank you all for listening in on this presentation. This is a second in a series of 4 presentations on water resource issues that run together and have overlapping themes. Back in November, we did a presentation on Verona's water resources, which basically looked at where our water comes from and where it goes and the infrastructure that we have in place to handle that. Tonight, we're going to be focusing on water characteristics of stormwater and how that differs from our water supply and from our wastewater. In January, we'll be looking at the sampling program that I had conducted during 2021, presenting a summary of those results. And then in February of 2022, we'll be talking about how we're developing plans for long-term maintenance schedule of our stormwater infrastructure, in particularly the stormwater basins. So tonight we're going to go over the big picture of stormwater. We're going to talk about why we do what we do with stormwater. We'll talk a little bit about the water-related cycles. I will very briefly go over the water-related utilities that the City of Verona runs, and then how water changes as it runs through the cycle, and then finally hitting some reminders on programs the city has, ongoing issues, and where you can find additional information. I always like to show this map of the continental United States, showing the Mississippi River Valley watershed, which is somewhere between 1/2 and 2/3 of the United States, and point out the fact that at the in the Gulf of Mexico, every year, spring, summer, fall, this hypoxic or dead zone develops as a result of all of the essentially pollution that runs off of the watershed and concentrates in the Mississippi River and discharges into the Gulf of Mexico. So this is a phenomena that expresses why we try to manage and work on water quality for stormwater to help address that little piece. And for us, the City of Verona is in the Upper Sugar River watershed. Our water drains to the Sugar River, which eventually drains into the Rock River and makes its way into the Mississippi in the northern part of Illinois, on the western edge of Illinois, across from Iowa. So something to keep in mind and understand that the work we do here in Verona, we're trying to address a nationwide problem. Let's just quickly review the water or hydraulic cycle. It starts with rain, falls down on the land. Some of that penetrates into the ground. Some of it runs off directly into streams. That water that percolates in becomes groundwater and makes its way to rivers and lakes. And that surface water that runs off is carrying sediment and nutrients for the streams. And that's one of the things that we're trying to control. Hits to the surface water, evaporation back up into the clouds, and then under certain conditions, cool weather, that will condensate and create precipitation. So that's the water hydraulic cycle. Verona has 4 water-related utilities that, excuse me, 3 water-related utilities that manage the water as it comes through Verona. So we've got our water supply, which is called the Verona Waterworks, that provides the water that comes out of your tap in your home or your hose or your business. That's drinking water. It's supplied by groundwater wells. The sewer utility is the utility that takes the water that has gone down your drains or flushed down your toilets and takes it to the Madison Metropolitan Sewerage District Treatment Plant. And then finally, we have the Verona Stormwater Utility, which handles rainwater and snow melt, and before it is discharged to the waters of the state. Again, the hydraulic cycle, and now this particular version shows a well. So Verona's water supply wells are pumping water out of the ground and then putting it into pipes and going out into the city. Very briefly, what you're looking at is a construction drawing for a street. And I want to point out the 3 utilities that show up in this drawing. So along the top part of the street alignment is where the water main is. It's a dashed line, and you can see the little dashes going off into the lots. Those are the water services. Down the center line of the street is the sanitary sewer line. That is always your deepest line, typically about 8 feet deep in the profile view. And again, we've got water or sewer connections coming from the home back into that sewer line. And then finally, we have the storm sewer, which is not as continuous as our water or sewer systems, because we're collecting water in the curb and then putting it into a pipe. And that is always our shallowest set of pipes in the ground. So I'm going to just quickly show you an aerial photo just to show you what section of the street that you saw, if you didn't, in fact, grasp that. So here's the aerial photo view with our water main in blue, our sanitary sewer in green, and our storm sewer in orange. I give more detail on these utilities in my November talk, and I'll be recording that to put back up on the library website for future reference if you want to go back to that. Verona's water supply is from groundwater, deep wells into bedrock aquifer. We have 6 wells. They vary in depth from 770 to 1,160 some feet deep. Typically, groundwater in these deep aquifers is hard water, meaning that there's a lot of mineral content in it. Typically, we'll have our hardness at about 340 milligrams per liter, expressed as calcium carbonate. The alkalinity, which is looking at the ability of that water to buffer acids, is at about 240 milligrams per liter. Calcium carbonate. Calcium carbonate is limestone. So hardness and alkalinity are complementary parameters. They're both expressed in this term of equivalency of calcium carbonate, but they're not the same thing. So they will move up and down together, but they will not necessarily be the same value. The chemical formula of limestone is CaCO3. So that's the calcium, C is carbon, O is oxygen, for those not familiar with the chemical formulations. Typically, groundwater supply is softened. Probably most of you will have water softeners in your home, and what's going on there is there's an exchange of the bivalent, that's the calcium and the magnesium in the water with sodium, and that makes the water softer. And essentially what it allows is formation of soap in the water a little bit easier. Softening water helps reduce lime buildup in plumbing. It extends appliance lives. It reduces soap use, but it increases chloride in wastewater because we're exchanging sodium chloride, salt, for that calcium carbonate in the water. This is used to set our water softeners. If you look on our website, the number recommended in Verona for setting that is 19.88 grains per gallon. This is a water softening terminology, which essentially equates to converts to that 340 milligrams per liter of hardness as calcium chloride. Put water hardness in the search box on the city website, and you'll get to this information. There's also a consumer confidence report available on the city website. Go to the water utility page or put consumer confidence report in that search box of the city website, and you'll get more access on the screening of contaminants that is required for our water utility. Switching gears now to talk about sanitary water. Our sanitary water is derived from our water supply, so it is a groundwater source with the addition of domestic pollution. So everything, all that, when you flush the toilet, where your waste goes, that's domestic sewage. From washing your dishes, what's going down the sink, that's domestic sewage. Our treatment operation is through Madison Metropolitan Sewerage District. If you use madsewer.org, that's where you can go to find the website and learn more about the Madison Met Sewerage Treatment Plant. One of the telltale parameters in sanitary water is the fact that there's ammonia. If we have any question on the source of a water, we would test and look for ammonia. If there's ammonia in there, we would know that it is likely that water might be leaking out of, for example, our sanitary sewer system. And that ammonia is that a chemical formula for ammonia is 3 hydrogens plus 1 nitrogen, and it's the nitrogen that's in the waste that is making the ammonia and causing that telltale parameter to identify that type of water if we have any questions on it. So what I'm really wanting to talk about and get to is talk about how stormwater is different from our groundwater and from our wastewater. And over the past 2 years, we've done a sampling program of our stormwater ponds, and we've been doing this to look at possible future phosphorus regulations, which may be coming down the pike for the city. And we need to understand the characteristics of our stormwater in a chemical way in order to understand what we might be able to do to manage that in the future. We're in particular looking at ways to reduce phosphorus in stormwater because that's our key limiting parameter for minimizing algae blooms. The stormwater sampling program looked at 3 basic areas: fundamental characteristics, so pH, alkalinity, hardness, conductivity, calcium, magnesium, potassium chloride. Those would be considered just fundamental characteristics of that water. We looked at nutrient levels, measured that in a couple of different ways. For nitrogen, there's a nitrate plus nitrite, and then there's an analysis called total Calgol nitrogen, and then phosphorus and potassium are considered nutrient elements. So we looked at those things together to see how our water looked at in terms of a fertilizer source, if you will, for algae blooms. And these parameters, if you, in the old days, if you bought fertilizer for your lawn, there would be a series of numbers. It might be 10-10-5 or 20-10-3 or something like that. And that was referring to the potassium, excuse me, the phosphorus, potassium, and nitrogen content of that fertilizer. So the idea of this, looking at these sets of parameters, was to identify how that the constituents in that water related to being a possible source of nutrients for algae bloom issues. And then water quality parameters include, we looked at chlorophyll A, total suspended solids, which is what we are currently regulated on, and then phosphorus. And then, yes, you are seeing that some of these parameters fall into multiple categories. So I just wanted to explain that there are reasons for looking at this set of parameters for what we're trying to understand down the road. We're not looking at everything that's in stormwater. Again, reviewing that hydrologic cycle. So we're looking at this piece now of rainwater and then running across the surface into, if you will, our stormwater detention facilities. I had an opportunity to grab a rainwater sample to get a quick look at what that looks like just in some of these fundamental parameters. Collected it, took it to the State Lab of Hygiene. That was collected on October 7th. We had a pH in the lab of 6.82, so very neutral rainwater, virtually no alkalinity. Limit of detection, that's what LOD is, excuse me, let me go back, is 20 milligrams. So we know it was less than that, very low alkalinity. And then TSS was total suspended solids, 5.2 milligrams. Again, a very low number. And I bring this up so that you can then look at how that compares to our stormwater water from our stormwater ponds. Our stormwater ponds will vary in pH from 6.9 roughly to all the way up to about 10. Alkalinity will go from 33 up to about 76. And our TSS samples anywhere from 2.2 up to 138 milligrams per liter. These ranges come from the 51 samples collected during 20 and 21 from 7 to 8 different stormwater ponds. So what I want to point out are the differences. Our pH can be very close to rainwater, but it can get very basic. And that's because of the algae in the water that is utilizing the nutrients. Alkalinity increases as that water is running across the ground and running down the curb line before it gets into our stormwater detention ponds. So it's picking up the debris, those fine particles, and dissolving that in the water, and that's becoming that alkalinity. And then in some cases, we've actually had less TSS in our stormwater ponds, but we've also gone, to a very high number relative to rainwater for TSS. I had an opportunity to get something that I knew was a groundwater sample this past year while we were working on the Lincoln Street stormwater facility. And this groundwater is different than our water supply groundwater in that it is coming from what would be referred to as the near surface aquifer, just a few feet below the ground surface, as opposed to 700 to over 1,000 feet deep in the ground. So our pH tends to be higher because it's gone through that geologic layer and picked up the constituents that make the water higher. There's our alkalinity from that sample 253, which matches up very closely to our typical number of about 240. And the TSS of that groundwater was about 20 milligrams per liter, right at about half as much as what we're seeing on our better water samples from our stormwater ponds. So water becomes harder or more alkaline as it goes through the hydrologic cycle. Water characteristics differ depending upon your source of water and where you're sampling it. And I want to bring this up just to make people aware of not understanding these differences and being a little bit blind to the subtleties of water leads to bad things happening, such as what happened in Flint, Michigan. And just briefly what happened there, and I'm certainly no expert, but there was a period for a long time, Flint, Michigan got its water from Detroit. It was piped up from Detroit, and that was a fairly expensive proposition. City of Flint was in some financial straits. Some people made some financial decisions to eliminate that source of water and go to the river water. And the big difference was Detroit's water was pre-treated and cleaned up because they also have a surface water source before it was delivered to Flint. And when Flint went to the Flint River for its water, they weren't treating that water before they were putting it in the system to the same level, or and consequently, the characteristics of the water that were now coming into the system really changed, and how the pipes in the system reacted to that water changed. And unfortunately, Flint had a lot of lead pipe water services, which we're fortunate in Verona that we only have copper services or plastic after the copper portion that the city puts in. And that caused the lead to leach out of the pipes and cause the high lead levels, along with other problems. So this business of understanding where the water sampled from and understanding that not all water is the same is the crux of what I wanted to talk about today. So here's that summary again of what happened to Flint, Michigan. So we're going through the sampling of our stormwater because we need to understand our water in order to manage it. And our sampling program, which I'll describe in January, is something that's over and above what we have to do for our stormwater currently. In contrast, we're constantly testing our water supply, water. Daily, we're monitoring certain parameters. Weekly, we're monitoring other parameters. We have those reportings. If you're interested in what our water quality looks like, go to that consumer confidence report that's available on the city website. We don't have to test our wastewater. That gets tested at Madison Met, but they are constantly testing the wastewater to monitor their parameters and looking for a variety of different things. So the work we're doing with stormwater and our testing program is trying to grasp what the characteristics of our stormwater are. Should at some point phosphorus become a more highly regulated parameter for stormwater for the city of Verona? And I'm aware that that is a possibility because of the fact that where we discharge our water, which is the Upper Sugar River, is listed as an impaired water for phosphorus by the Department of Natural Resources. So just to review some of those ongoing water resources issues, we've constantly got chloride levels that seem to be constantly increasing in our water supply. Source of that might be from salt on the streets, it might be from water softening, but that increasing chloride level is a concern for the sewerage district, because chloride is an element that you can't break it down any further, and it gets difficult to remove. And it seems like we're getting closer and closer to those levels in our wastewater where we have to be concerned about that. So Madison Met has been looking at chloride levels in our water and in their wastewater for the past several years. Nutrient overloads to our surface water, that's what we're really talking about with this phosphorus and the concern for algae blooms, and why we would be looking at that. The interesting thing about stormwater and these nutrient overloads is if we can take this one key parameter out, phosphorus, we can limit, we won't totally eliminate, but we can minimize the algae blooms that would happen in our stormwater ponds, and also cause things like the dead zone down in the Gulf of Mexico. Continuing on, grease and oil clogging in our sewer pipes, that creeps up all the time, and people have to be conscientious of what they dump down their sewers. Pharmaceuticals, please be conscientious about where you dispose of those. They do not belong being flushed down the toilet. Plastics, not only just the large plastics clogging things, but as those plastics break down, they become smaller particles that can get consumed and can lead to problems. And then there's a whole class of carcinogens that are possibly coming off of the land from contaminated sites that are always a challenge. PFAS is an example of that kind of contamination that's become an emerging concern. I'd like you to be a conscientious water person. Consider installing a rain barrel, consider installing a rain garden. The city has some programs to help you with those. Try to keep the trash out of the street, your yard waste out of the street. Consider adjusting your water softener to cycle a little bit less than the recommendation. You could move that down from, typically you're cycling at about every 800 gallons. If you go to every 900 gallons, I don't think you'd see a big difference, and there would be that much less chloride going into the system. Consider joining USRWA, which is the Upper Sugar River Watershed Association. They are a partner with the city of Verona. USRWA provides volunteer opportunities. They have a fundraising event coming up next year on June 5th. That's a bike and paddle event that gives you a good opportunity to get in touch with the watershed, really get a feel on a bike and in a boat for the watershed. Our rebate programs for rain barrel, $10 per rain barrel up to 4 rain barrels, and we've got a 50% cost share for native plants used in rain gardens where we're capturing water before it's running off of your property. The city offers some mapping assistance. You can go and apply for these things online. If you go in to the city website and put in either rain garden or rain barrel rebate, you will get the forms to apply for that. That program may be changing in the near future, but currently go to the website, put in those search words, apply online. I'd like to just briefly talk about yard waste, brush and leaf management. City does not collect yard waste. We have yard waste drop off at our public works department. We do on a regular basis collect brush and larger woody vegetation that you've trimmed from your yard. There's a couple of links to our website. During the fall, the city picks up leaves, and we do ask that you put them into the curb because of our method of collecting. That may change at some point, but for now, that is our methodology. I'd like to remind you of our follow-up presentations in cooperation with the library. We've got 2 more scheduled in January and February of 2022. Again, that one in January is going to be on stormwater quality, where I'll summarize the testing results from the past couple of years. And then in February, I'm going to be talking about how we're putting together a view of managing and maintaining our stormwater ponds, in particular, how we're prioritizing cleaning out stormwater ponds. So with that, I'm going to end this presentation. Thank you very much. I've appreciated your time. So have a great day and be water conscious. Thank you.